Welcome to solverfy.
Hello students. In this question, 1 meter cube of the fuel consists of the following combination of the gases. We have to find out the volume of the oxygen that require for the complete combustion of this fuel. At first, we are going to find out the volume of the gas. So for that, the percentage of the gas is multiplied with the volume of the fuel and divided by 100, and substituting the value, the volume percentage of the gas into 1 divided by 100. So this will be equal to volume percentage divided by 100. On solving this, the volume of the methane will be equal to 0.17 meter cube, and ethane is 0.20 meter cube, and propane is 0.15 meter cube, and hydrogen is 0.05 meter cube, nitrogen gas is 0.02 meter cube, and the carbon monoxide is 0.41 meter cube. So now we are going to calculate the volume of the oxygen that is required for combustion of each of the individual gases. So the combustion equation for the methane can be written as follows. Methane combined with the 2 moles of oxygen and gives us carbon dioxide plus 2 moles of H2O. Here the methane and the oxygen are in 1:2 ratio. Therefore, the volume of the oxygen will be equal to 2 into volume of the methane, that is 0.17, which will be equal to 0.34 meter cube. And coming to the next gas, that is ethane, C2H6. So this would combine with the 7 moles of oxygen. 2 moles of ethane will combine with the 7 moles of oxygen and gives us 4 moles of carbon dioxide plus 6 moles of water molecule. So at first, here the relationship between the ethane and the oxygen is in 2:7 ratio. Therefore, the volume of the oxygen will be equal to 7 divided by 2 into the volume of ethane, which is equal to 0.20 meter cube. On solving this, it will be equal to 0.7 meter cube. And coming to the next gas, that is propane, C3H8, will combine with the 5 moles of oxygen and gives us 3 moles of carbon dioxide plus 4 moles of water molecule. So here the propane and the oxygen are in 1:5 ratio. Therefore, the volume of the oxygen consumed will be equal to 5 into volume of propane, which is equal to 0.15. This will be equal to 0.75 meter cube. And coming to the next gas, that is hydrogen, it would combine with the half mole of oxygen and gives us H2O. And here the hydrogen and the oxygen are in 1:1/2 ratio. Therefore, the volume of the oxygen will be equal to 1/2 into volume of the hydrogen, which is equal to 0.05. On solving this, it will be equal to 0.025 meter cube. And coming to the next one, that is nitrogen, that will combine with the oxygen and forms as nitrogen monoxide. So this is the complete combustion reaction, and the nitrogen and the oxygen are in 1:1 ratio. Therefore, the volume of the oxygen will be equal to the volume of the nitrogen, which is equal to 0.02 meter cube. And coming to the last one, that is carbon monoxide, it will combine with the half moles of the oxygen and gives us carbon dioxide. Here the carbon monoxide and the oxygen are in 1:1/2 ratio. Therefore, the volume of the oxygen will be equal to 1/2 into the volume of the carbon monoxide, 0.41. On dividing this, it will be equal to 0.205 meter cube. Now we are going to find out the volume of the oxygen that is used for the combustion process, which will be equal to volume of the oxygen that has been used for the combustion of methane plus the volume of the oxygen that has been used for the combustion of ethane plus the volume of the oxygen used for the combustion of propane, and for oxygen 0.025 plus, and for nitrogen 0.02, and for carbon monoxide 0.205. On summing up this, the volume of the oxygen used for the complete combustion of the given fuel will be equal to 2.04 meter cube. This is the answer to this question. Hope you find this video useful. Thank you.